Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to use trigonometric functions to find the altitude and base of an isosceles triangle, how to find the area of regular polygons, and how to determine the origins of the number pi. How are we learning it? Through the Inscribed regular polygons notes and the Inscribed regular polygons assignment. When can we use this information? To determine the area and volume of circular or cylindrical objects, which could help to determine how much fluid a bucket or water jug can hold. How do we know we learned it? By getting a score of 4 on the Inscribed regular polygons assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Inscribed regular polygons notes, and then I'll give you time to complete the Inscribed regular polygons assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we will go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Irrational Numbers study guide and any incomplete assignments that you may have. Let's take a look now at the Inscribed regular polygons notes. Our notes begin with the learning goals and success criteria. Now, what is an inscribed polygon? An inscribed polygon is a shape inside of a circle in which all the points are on the circle. So if we look here, we have some kind of a four-sided figure here, and every point falls on the circle. This is an inscribed polygon. Now, what is a regular polygon? A regular polygon is a shape with all the sides and angles being exactly the same. So in this case, we have an inscribed regular polygon. So there's 1, 2, 3, 4, 5, 6 sides. And notice all the sides should be exactly the same length. And all of the angles are the same. So this angle is 60 degrees, this angle is 60 degrees, 60, 60, 60, 60. And each one of these angles is all 120 degrees. So these are regular polygons. Now, in this case, we're given a regular polygon inside of a circle. So we have a square in this case. And the question is, if we were to connect all these dots, how many isosceles triangles would we have? So if we connect the dots through here, so we draw from the center to each point, notice now we end up with 1, 2, 3, 4 triangles. So what we should notice as we go through this is the number of isosceles triangles is equal to the number of sides. So there's 4 isosceles triangles. Now, what is the angle measure of each of these angles? So the angle measure is equal to 360 degrees because there's 360 degrees in a circle. So 360 divided by the number of triangles, which in this case is 4. So if we divide 360 by 4, we get 90. So the angle measure is 90 degrees. Now, what is the length of the base? How far from A to B? So if we look at one of these triangles here, we'll just look at one at a time. So the length of the base, each of these sides is 1, because we're assuming that this is a unit circle, so that means the radius is 1. So if each of these is 1, then we can figure out what this base is based off of that. Well, in order to do that, we're going to need to be able to cut this in half. So now we have a right triangle here. So this side is 1. We don't know this side and we don't know this side yet. We know that the angle measure here is half because we started out at 90 and we cut it in half. So half of this would be 45 degrees. So each of these angles here is 45 degrees. So we end up with half the base length being sine 45 degrees. So that means then that the full base length would be double this, so that's 2 sine 45 degrees. So that's the length of our base. And when we plug that into our calculator, we get 1.41421. Now we need to find this side length. Well, we should notice this is 45 degrees, and this is 1. So we need this side, which is the adjacent side. So we can use cosine to find that. So it's cosine of 45 degrees is equal to a over 1. And remember, anything divided by 1 is just itself. So we just end up with cosine of 45 degrees. And when we plug that into our calculator, we end up with 0.70711. Now we can find the area of each one of these triangles. So the area of a triangle is 1/2 the base times the height. So that's 1/2 of this, the base, times the height or the altitude here. So we get 1/2 of 1.41421 times 0.70711. And when we enter that into our calculator, we get 0.5 as our area. So each of these triangles has an area of 0.5. Well, the area of the polygon then is 4 of those, because there's 4 triangles, so 1, 2, 3, 4. So if we multiply 0.5 times 4, we get 2. So that's how we can fill in our table for a 4-sided figure. Now let's look at a 6-sided figure. Well, we're going to do it the same way. So we connect all the dots. So now, how many triangles did we end up with? Well, we ended up with 1, 2, 3, 4, 5, 6. So like I said earlier, the number of isosceles triangles is equal to the number of sides. Now, what's the angle measure? Well, we're going to take 360 degrees and divide it by the number of triangles. So we get 360 divided by 6, which is 60 degrees. Now we're going to find the length of the base. So we're going to pick out one of the triangles. We'll pick this one. And we know that each of these sides is 1 because we're working with the unit circle. So that means that each of the radii are 1. So now, if we draw a line to split this in half, that'll give us our altitude, and then we can find this part of the base and this part of the base. So when we split it, we end up with 60 degrees being split in half, which is 30 and 30. So now we can go ahead and find the base using our sine function. So we know that 1/2 of the base, because all we get is this part here, so 1/2 of the base is equal to sine of 30 degrees. So that's equal to 1/2 the base. Now, if we want to find the full base, we need to multiply it by 2, because these two are exactly the same. So now it would be 2 sine 30 degrees is equal to the base. When we enter that into our calculator, we get that the length of the base then is 1. Now we need to find the altitude, which is this side here. Well, this one is the adjacent over the hypotenuse. So we would do cosine of 30 degrees. And the cosine of 30 degrees, if we put that into our calculator, we get 0.86603. Now we want to find the area of this whole triangle here. So if we do that, the area is 1/2 base times height. So it's 1/2 the base times the altitude. So that's 1/2 times 1 times 0.86603. And when we put that into our calculator, we end up with 0.43301. And now to find the area of the polygon, we need to multiply it by the number of triangles that we have. So we have 6 triangles total. So we're going to multiply 0.43301 by 6. And when we do that and put that into our calculator, we end up with 2.59808. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account. And it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click Start the Activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the Inscribed Regular Polygons assignment. The assignment begins with our learning goals and success criteria. If we scroll down, there's a link here that takes us to our Desmos activity. Go ahead and click on that link. And it should take us to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll click Next. It gives an assignment overview that says that we're going to look at inscribed regular polygons and examine how if we continue to add sides to the polygon, the negative space in the circle starts to shrink as we continue to add more and more sides. So we're given a four-sided regular polygon, and we're asked to fill in the table. Now, the number of sides of the polygon is, we said it was four-sided, so there's four sides. Now, if you used your notes, you should know how these things work. So the number of congruent triangles should be 4 as well, because it's always going to match the number of sides. The angle measure is going to be 360 divided by the number of triangles, which in this case is 4. And when we do that, we get that each angle then is 90 degrees. The length of the base is 2 times the sine of 1/2 of the angle that we came up with. So this angle was 90. We cut it in half, so this is really 45 degrees now. So we can say that the base is 2 sine of 45 degrees, which when we put that into our calculator, we end up with square root of 2. And you can go ahead and enter that into your calculator and see what that rounds to be. Then the altitude, which is this side here, the altitude is cosine of 1/2 of the angle measure that we came up with, so 45 degrees. So it's really cosine of 45 degrees, which is square root of 2 over 2. And again, we can round that and figure out what that is. Then we'll find the area of one of the triangles. Remember, the triangle is 1/2 the base, which is here, times the altitude or the height, which is here. So we multiply this out, and we multiply 1/2 times square root of 2, which is just square root of 2 over 2, times square root of 2 over 2, and we get 2 over 4, which is just 1/2, or we can say it as 0.5. Now the area of the polygon, we're going to multiply the area of the triangle times how many triangles there are. So the area was 0.5, and there's 1, 2, 3, 4 triangles. So 1/2 times 4 is 2. So that would be the area of the polygon. Notice we have quite a bit of negative space here along the outside that's not included in the polygon. And then we'll click Next. And now we're going to do a 5-sided figure. So we'll do this again using the same rules we just came up with. Then again, we'll keep going through this. And then we're going to continue the process. So now we're going to say, using the formulas that we came up with, can we know what a 40-sided figure is going to look like, and a 60-sided, and a 360-sided figure? And then at the end, it says, what is the area of a 360-sided polygon? How are the areas of the polygon and the circle similar? So you should recognize that they're almost completely perfectly touching. There's almost no negative space. And then why do you think this occurs? That it's similar to pi r squared. So you'll go ahead and figure that out. And then when you're done, you'll go back to your Google form and click Next. This will send you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.